All right, we're going to do 3 sections in this video. We're going to go 1.6, 1.7, and 1.8. They're very short lectures, so um, I just put them on the one video. So for 1.6, we're going to be subtracting integers. Subtracting of integers is very similar to adding integers because you can always make a subtraction problem into an addition problem by what we like to call crossing the line, changing the sign. So first step is this, is if to solve a subtraction problem involving positive integers, if you look to see if the second number can be subtracted from the first number, just to subtract it like you've always have. Meaning like if I have 8 minus 5, this is an easy subtraction problem. I know that this is going to be 3. So you don't have to do any crossing the line, changing the sign. But if you're given something along the lines of um, by subtracting like by a negative number, your best chance is to use the subtraction problem by crossing the line, changing the sign. And the example they give us is 12 minus a negative 4. And what they mean by crossing the line means making an addition problem. And then changing the sign, you're only changing the second value, which means you're going to be changing the sign of from a negative 4 to a positive 4. So now 12 plus 4 equals 16. That means that 12 minus a negative 4 must equal 16 as well. But if you look at these values here, you can also make those into addition problems by crossing the line, changing the sign, crossing the line, changing the sign. And then if you do use addition, then you just follow the same rules that we used for adding integers. If we have, we come to upon 1.7, where we're going to be multiplying and dividing integers. Just like in adding and subtracting integers, there are rules that we need to follow. The rules is when the signs are the same, the answer is always positive. When the signs are different, your answers are always negative. So one thing to keep in mind is that 2 negatives make a positive. So if you look on top here, we have 2 times 3. All of these answers are going to have 6 involved in it. So 2 times 3 is 6. And since they're the same sign, it's going to be a positive 6. 2 times a negative 3, they're 2 different signs. So it's going to be a 6, but it's going to be a negative 6. And then negative 2 times a negative 3, they're the same sign, so it's going to be a positive 6. If you look at examples A through E, all I want you to do is tell me whether the answer is going to be positive or negative. So for A, I'm multiplying by 2 negative numbers. Their signs are the same, so that's going to be positive. For B, I'm dividing by 1 positive and 1 negative. They're different signs, so it's going to be negative. For C, I'm multiplying by a positive to a negative, 2 different signs. It's going to be negative. D, I'm dividing by 2 negative numbers, so that means that this is going to be a positive. And then for E, I'm dividing again by 2 negative numbers, so this is now going to be positive. Here I get to multiply or divide each of these examples. So if I have 12 times 5, same sign, so it's going to be positive, so it's going to be a positive 60. 28 divided by 14, both positive numbers, same sign, so it's going to be a positive 2. 6 times negative 22 is going to give me a negative number because they're different signs, and it's going to be a negative 132. For D, I have negative 17 multiplied by negative 20. And since they're the same sign, it's going to be positive, so it's going to be positive 340. For E, I have negative 51 divided by negative 3. So same sign, so I know it's going to be a positive number. It's going to be a positive 17. Last section in chapter 1 deals with the coordinate plane. And if you look here, this is an example of the coordinate plane. The coordinate plane is formed by the intersection of a horizontal line called the x-axis and a vertical line called the y-axis. The axes meet at a point 0, 0 called the origin and divide the coordinate into what is called 4 quadrants. Points in a plane are represented by an ordered pair. The first number is denoted as the x-coordinate, and the second number is denoted by the y-coordinate. The example they give you in here is trying to find point negative 2, 1, which is right here. And here's how they find it. Is let's take a look. Let's make a little dot at 0, 0, which is the origin. You always start at 0, 0, and then you identify where the point is. First thing you have to do is look left to right. If the point is towards the left, you move in a negative x direction. If it's moving to the right, you move in a positive x direction. In this case, it's moving in a negative x direction, so it's going to go 1, 2. So it's negative 2 units to the left. So that's where they get this negative 2 from. And then to find the y-coordinates, you have to look up and down from 0, 0. If it's pointed up from 0, 0, or from the origin, it's going to be a positive y-coordinate. If it's positioned below the origin, then it's going to be considered a negative y-coordinate. In this case, that point is pointed above the origin, so it's going to be a positive number, and so I'm going to move it up 1, and it comes across as negative 2, 1. That's where we get that from. Looking at the quadrants, I have quadrant 1, 2, 3, and 4. You know, quadrant 1 is the upper right-hand corner. Quadrant 2 is the upper left. Quadrant 3 is the lower left, and quadrant 4 is the lower right. If you're trying to figure out where numbers are in relationship with the quadrants, all you have to do is this. So if you have a x and y coordinate, anything in quadrant 1, the x value is always going to be positive, and the y value is always going to be positive. If it's in quadrant 2, the x value is going to be negative, and the y value is going to be positive. If you're looking for points in quadrant 3, your x value is always going to be negative, and your y value is always going to be negative. And then lastly, in quadrant 4, your x value is going to be positive, and your y value is going to be negative. Now there's 2 other places that these quadrants could be, and they could also be located on the x or y axis. So let's say I have a point that's right here. That point is 5, 0. Okay? That one is located on the x-axis. The reason why it's located on the x-axis is because our y-coordinate is 0. So anytime our y-coordinate is 0, it's located on the x-axis. Same thing goes, like, say if I were to do something like make a dot right here, that coordinate plane is 0, negative 3, and since our x-coordinate is 0, it's located on the y-axis. Okay? For examples 3 through 10, they want me to give to identify the coordinates of the points. So first one I look at is A, which is right here. It's to the left of 0, so it's going to be a negative x value. So, and it looks like it's a negative 3. And then it's above the origin, so, and it's moved up 3 units. So my coordinates for A are negative 3, comma 3. For B, which is right here, I look at it, look at 0, comma 0 first, and I notice that it's to the right of 0, comma 0, so that means it's going to be a positive x value, and it only goes 1 unit, so it's going to be a positive 1, and then it moves up from the origin, so it goes 1, 2, 3. If I look at C, which is right here, it is moved to the left, so move to the left to make it a negative 5, and it doesn't go up or down, so it's going to be a coordinate of 0. 6 for D, which is right here. It goes to the left, so it's at a negative 4, and it's going to go down, which is at a negative 3. If I look at E, which is right here, it doesn't go left or right at all, so it's going to be left at 0, comma, and then it goes down, which is a negative 2. F, right here, goes to the right of 0, so it's going to be a positive x value, and it's stated it's a positive 4. And then for the up and down, it goes down 1 unit, and so it's in a negative 1. For G, I have located right here, and it goes to the left in an x value, but it's in between negative 2 and negative 3. So I can say that coordinate for the x, for that x coordinate is going to be a negative 2.5. It's not, that coordinate's not an integer, but it's in between there, and we can estimate that. And it goes up 1, 2 units. The last one is H, which is right here. And it goes to the right a positive 3 units. And then it goes up 1, and it's in between 1 and 2, so I can say that this value for y is 1.5. For examples like 11 through 22, they're asking you to plot the point and the coordinate, and then they want you to describe the location. Plotting the point is this. So if I had 4 comma negative 1, that means that I am going 4 positive units to the right, and then I'm going 1 positive unit up. So this coordinate right here is 4 comma 1. And then like what I talked about on the page before, it's asking you to describe the location. So it could be either in 7 places. It could either be in quadrant 1, quadrant 2, quadrant 3, quadrant 4. It could be on the x-axis. It could be on the y-axis, and it can also be on the origin. So since it's both a positive and a positive x and y coordinate value, I can say that this is in quadrant 1. Okay? Now if I look at, say, like 18, that would be negative 3, so that's going to be left 3, so 1, 2, 3. And it's going to go down 4, so 1, 2, 3, 4. So this point right here is negative 3, comma, negative 4. Like I said before, if it's in quadrant 3, both values are negative. So this is where I can say this is in quadrant 3. Now, let's take a look at negative 3 comma 0. Here, it goes to the left 3 units, 1, 2, 3. And then it doesn't go anywhere else in the y position, so it's left at that point. And since my y coordinate is 0, that means it lies on the x-axis. Same thing goes for like saying something like 17. It doesn't go anywhere left and right, but it goes down 5 units. So it's 1, 2, 3, 4. So it's like somewhere right around here. So this is where 0, comma, -5 is located. And that one is located on the y-axis. The only time in that it's ever located on the origin is when it's at coordinate 0, comma, 0. All right? And that is being able to subtract integers, multiply and divide integers, and use a coordinate plane. Hope this helps. Till next time.